Velocity of a pulse propagated through a slinky. A slinky is a pre-compressed helical spring. It was invented in 1943 by Richard James as a toy. Later, the slinky was used in physics classes to demonstrate wave properties, forces, and energy states, as it can stretch and reform itself with the aid of gravity. It can even appear to levitate for a period of time. Principle: wave velocity is the distance travelled by a wave per second. When the wave travels a distance lambda in time t, its velocity v is distance by time. That is, v is equal to lambda by t. Materials required: slinky, meter scale, stopwatch, fixed hook. Procedure: tie one end of a slinky by placing it lengthwise on the smooth surface of a table on a fixed hook. Hold the free end of the slinky and stretch it. Move the hand periodically and uniformly at right angles to the length of the slinky. Observe the propagation of the wave, the formation of crests and troughs along the slinky from the free end to its fixed end. A timer is started at a particular point and is stopped when it reaches a specified distance. Note the distance travelled and the corresponding time taken. To obtain the longitudinal waves, compress the free end of the slinky periodically. Watch the movement of the wave from the free end of the slinky to its fixed end. The movement of the wave is associated with the formation of compressions and elongations. Using a timer, note the time taken for a wave propagated at a particular distance. Calculate the velocity of the wave using the relation wave velocity is equal to the distance travelled by the pulse divided by time taken.
To determine the velocity of a pulse propagated through a stretched slinky. A slinky is a long helical spring, usually made of steel. It is flexible and has appreciable elasticity. It produces transverse waves when one end is fixed and the other end is stretched and given a jerk at right angle to its length. It produces longitudinal waves when compressions are given at regular intervals of time at the free end of the slinky. A disturbance which propagates through a medium is called a wave.
Ma'am, how can we determine the velocity of a pulse propagated through a stretched slinky?
Velocity is the distance travelled by the wave per second. Velocity is equal to length covered upon time taken. Centimeter per second or meter per second. Let's do an experiment to determine the velocity of a pulse propagated through a stretched slinky. Our aim here is to determine the velocity of a pulse propagated through a stretched slinky. The materials required are a slinky or spring of negligible mass, a stopwatch, a meter scale, and a fixed support with a hook. Procedure: tie a spring of negligible mass to a rigid support. Stretch the spring and create a disturbance in it. Simultaneously, switch on the stopwatch. Note how the disturbance is being transferred to the fixed end. Note the time taken up to which the disturbance reaches the other end. Measure the natural length of the spring. Repeat the experiment to take at least 3 readings with different lengths of the same spring. One can produce transverse as well as the longitudinal type of pulses in a spring and find the time taken and thereby the velocity. Observations: natural length of the spring in centimeter, time taken by pulse in second, velocity in centimeter per second, longitudinal, L1 is equal to, L2 is equal to, L3 is equal to, transverse, L1 is equal to, L2 is equal to, L3 is equal to. Result: the velocity of a pulse created in a spring will be different for different lengths. Precautions: hold the slinky in such a way that the slinky should be parallel to the ground. While giving the jerk, slinky itself should not move as a whole. The start and stop of the watch have to be done very carefully, since it may make the velocity vary. The stopwatch may be of least count for accuracy of readings. The spring should have no mass since it will change the velocity. Measure the length of the spring accurately.
Thank you, ma'am. This experiment has made the concept very easy to understand.